Saturn is the jewel of our solar system, majestic, golden, crowned with rings. Neptune is the beast, a world of supersonic winds and storms that rage across an endless ocean of blue. But between them lies something far stranger. At first glance, it doesn't look dangerous. No towering storms, no glowing rings, no volcanoes, no dramatic colors, just a pale blue sphere, drifting silently through the darkness, calm, cold, almost forgettable. And that may be the greatest illusion in our entire solar system, because beneath those quiet clouds is a planet that refuses to obey the rules, a world where the sun rises only once every 42 years, where seasons last longer than an average human lifetime, where diamonds may rain through oceans no spacecraft has ever seen, where the magnetic field twists through space like nothing else we've ever discovered. This is Uranus, a planet that doesn't simply orbit the sun, it rolls around it. Every other major planet spins like a top. Uranus spins like a barrel, and somewhere in its distant past, something happened, something so unimaginably violent that even 4.5 billion years later, the scars are still visible. Tonight, we're going to investigate one of the oldest crime scenes in the solar system. If you could travel back 4.5 billion years, the solar system would be almost unrecognizable. There were no peaceful planetary orbits, no stable worlds, only chaos, millions of rocky bodies, icy giants, and newborn planets, all competing for the same space. Collisions were inevitable. Some built worlds, others destroyed them, and one of them may have changed Uranus forever. Today, its axis is tilted by an astonishing 98 degrees. Instead of spinning upright like Earth or Jupiter or Saturn, Uranus lies almost completely on its side. Imagine taking our own planet and tipping it over until the North Pole pointed almost directly toward the horizon. That's Uranus. No other major planet behaves this way. For decades, astronomers searched for an explanation. The leading theory is both simple and horrifying. Early in its history, Uranus may have been struck by a massive protoplanet, possibly 1 to several times the mass of Earth. The impact wasn't enough to destroy the planet. Instead, it did something even stranger. It knocked an entire world onto its side. The collision released an unimaginable amount of energy, enough to reshape the planet forever. But the tilt was only the beginning, because once Uranus fell over, its seasons became unlike anything else in the solar system. Here on Earth, our seasons change every few months. Spring becomes summer. Summer becomes autumn. Winter eventually gives way to spring again. The rhythm feels natural, predictable, and comforting. On Uranus, there is no such rhythm. One orbit around the sun takes 84 Earth years, and because the planet is lying on its side, its poles spend years pointing almost directly at the sun. Imagine standing near the North Pole of Uranus. The sun slowly rises, then it simply refuses to set. For the next 42 Earth years, day never ends. The sky changes, the seasons shift, but the sun remains always there, always watching. Then, almost without warning, the opposite begins. The sun disappears, not for one night, not for one winter. For another 42 years, entire generations would live and die without witnessing a sunrise if life somehow existed there. Its understanding of time would be completely different from our own. But these impossible seasons create something even stranger. They influence an atmosphere unlike anything scientists expected to find. In January of 1986, NASA's Voyager 2 became the first, and so far, the only spacecraft to visit Uranus. After traveling more than 3 billion kilometers, it finally arrived. What it found was disappointing, or so it seemed. The photographs showed little more than a pale blue sphere. No giant storms, no colorful cloud bands, no dramatic features, just a smooth featureless billiard ball. Some scientists even nicknamed it the most boring planet. But there was one problem. Nature is rarely that simple. As telescopes improved and astronomers began observing Uranus in infrared wavelengths, the quiet planet suddenly became alive. Hidden storms emerged from beneath the haze. Towering clouds appeared and vanished. Powerful winds, hundreds of kilometers per hour, circled the planet. It had never been asleep. We simply couldn't see its face. And beneath those clouds, things become even more extraordinary, because despite being called an ice giant, there is almost no ordinary ice. The name ice giant creates the wrong image. It makes us picture frozen glaciers, solid ground, a world buried beneath endless sheets of ice. Uranus is nothing like that. As you descend through its atmosphere, pressure rises to unimaginable levels. Hydrogen, helium, water, ammonia, and methane are compressed into a dense, superheated fluid. There is no clear surface, no place to stand, only deeper and deeper into a planet that slowly transforms into something almost alien. Then, far below the visible clouds, physics begins doing something remarkable. Laboratory experiments suggest that under enormous pressures, methane molecules can break apart. The carbon atoms forced together by crushing pressure may crystallize into diamonds. If those models are correct, countless diamonds could be forming deep inside Uranus, before sinking slowly through its interior, like glittering rain falling into an endless dark ocean. No human eye will ever witness the spectacle. Yet it may have been happening for billions of years. But perhaps the strangest mystery isn't what happens inside Uranus. It's what doesn't happen. Unlike Jupiter, unlike Saturn, unlike Neptune. Uranus barely radiates any heat of its own. It's as though someone extinguished the furnace inside an entire planet. If the sideways rotation wasn't strange enough, Uranus has another secret, one that has puzzled scientists for decades. Every major planet with a magnetic field follows the same basic rule. The field is generated deep inside the planet, and it emerges from somewhere close to the poles. Earth works this way, Jupiter works this way, Saturn works this way. Even the Sun follows this pattern, but Uranus doesn't. Its magnetic field is tilted by nearly 60 degrees from its axis of rotation, and even stranger, it isn't centered inside the planet. It's displaced hundreds of kilometers to one side. Imagine placing a bar magnet inside a football. Now slide that magnet almost halfway toward the edge and rotate it until it points in a completely different direction. That's essentially what Uranus has done. No one expected a planet to behave like this. As Uranus spins, its magnetic field tumbles through space. Instead of forming a neat protective bubble like Earth's, the magnetic field twists, warps, and corkscrews behind the planet. If a spacecraft were orbiting Uranus, the surrounding magnetic environment would change dramatically every single rotation. It's one of the most bizarre magnetospheres ever discovered, and despite decades of research, scientists still don't know exactly why it exists. Some believe the magnetic field is generated much closer to the surface than Earth's. Others think the strange layers of electrically conducting water and ammonia deep inside the planet create a magnetic dynamo unlike anything else in the solar system. Whatever the answer, Uranus reminds us that nature rarely follows our expectations. Just when we think we've figured out the rules, it invents new ones. But the planet itself isn't the only broken world in this system. Orbiting this frozen giant is one of the strangest moons ever discovered. Most moons tell a simple story. They form, they cool, they collect impact craters over billions of years. Miranda looks as though someone tore the pages out of that story and stitched them back together in the wrong order. At only 472 kilometers across, Miranda is one of Uranus's smallest major moons, yet its surface is unlike anything else we've seen. Gigantic cliffs, deep canyons, terraces, ancient cratered plains, and oddly smooth regions all packed together like pieces from entirely different worlds. When Voyager 2 flew past in 1986, scientists could hardly believe what they were seeing. It didn't resemble a normal moon. It resembled a cosmic patchwork. One leading theory suggests that Miranda suffered a catastrophic collision early in its history. The impact may have shattered the moon into countless fragments, but unlike a shattered glass, gravity slowly gathered those pieces together again over millions of years. They merged into the strange world we see today, a moon rebuilt from its own ruins. If that's true, Miranda isn't simply old. It's a survivor, and nowhere is that history more dramatic than along the edge of Verona Rupees. Imagine standing at the edge of a cliff. Now imagine that cliff is more than 20 kilometers high, over twice the height of Mount Everest. This is Verona Rupes, the tallest known cliff in the entire solar system. On Earth, a fall from such a height would be unimaginably short. Air resistance would quickly limit your speed. The impact would come within minutes. Miranda is different. Its gravity is so weak that falling becomes something entirely unfamiliar. If you stepped off the edge, you wouldn't plummet. You would drift slowly accelerating, almost floating through the darkness. For nearly 12 minutes, the landscape would pass beneath you in complete silence. No rushing wind, no birds, no sound at all. Only the pale blue disk of Uranus growing larger in the sky above. It's a haunting thought, not because anyone will ever make that jump, but because places like Miranda remind us just how strange the laws of physics can feel beyond Earth. Yet even Miranda may not survive forever. The Uranian system appears peaceful. 27 moons, thin dark rings, and a silent blue giant. But beneath that calm, everything is still moving, still evolving, still colliding. Computer simulations suggest that several of Uranus's inner moons follow unstable orbits over millions of years. Their paths may eventually cross. Some scientists predict that moons like Cupid and Belinda could collide. Others may be shattered by gravitational interactions long before that happens. The timescales are enormous, far beyond human civilization, but in the language of astronomy, the process has already begun. Nothing in the universe remains perfectly still. Even entire moon systems can slowly unravel. The solar system is often imagined as a perfectly balanced machine. In reality, it is a dynamic place. A place where gravity constantly reshapes the future, one orbit at a time. And yet, despite everything we've learned, our understanding of Uranus is surprisingly incomplete, because humanity has barely visited this world at all. On January 24, 1986, Voyager 2 made history. After a journey lasting more than 8 years, it became the first spacecraft to visit Uranus. It would also become the last. The encounter lasted only a few hours, just enough time to capture thousands of photographs, study the atmosphere, discover new moons, measure the magnetic field, and forever change our understanding of this distant world. Then, without slowing down, Voyager continued onward, toward Neptune, toward the edge of the solar system, and eventually toward interstellar space. Since that day, no spacecraft has returned. We've placed orbiters around Jupiter. We've explored Saturn for over a decade. We've landed robots on Mars. We've even flown through the atmosphere of Titan. But Uranus has remained alone. Not because it isn't important, but because it is distant, expensive, easy to overlook, and perhaps that's exactly why it deserves another visit. There is something strangely poetic about Uranus. It has no brilliant rings like Saturn, no great red spot like Jupiter, no towering volcanoes like Io, no oceans beneath icy shells like Europa. At first glance, it seems like the least interesting giant planet in our solar system, but the universe has a habit of hiding its greatest mysteries behind the simplest appearances. A planet knocked onto its side, possibly by one of the most violent collisions in solar system history. A world where the sun refuses to set for 42 years. An atmosphere so cold that it is the chilliest planet we've ever measured. A magnetic field that twists through space like no other. A moon that appears to have been shattered and rebuilt from the ruins. And deep below its quiet blue clouds, perhaps an endless rain of diamonds falling through darkness for billions of years. We've only seen this world once, one spacecraft, a few fleeting hours, then silence. For nearly 4 decades, Uranus has continued its lonely journey around the sun, unwatched, unexplored, still keeping secrets. But that may finally change. NASA has identified a dedicated Uranus orbiter and probe as one of its highest priorities for the coming decades. If approved, the mission could launch in the early 2030s, arriving sometime in the 2040s. For the first time, humanity would remain there, orbiting, watching, listening, perhaps discovering that everything we thought we knew was only the beginning, because every time we visited a new world, the universe has surprised us. Mars wasn't just a dead desert. Europa wasn't just another moon. Titan wasn't just a frozen rock. Maybe Uranus isn't just another planet either. Maybe it's the missing chapter in the story of how our solar system came to be. Until then, it continues to roll silently through the darkness, a frozen giant tilted against the rules, waiting for someone to come back. Because in the end, the greatest mysteries aren't always the brightest. Sometimes they're the ones we've barely looked at. If you enjoyed this journey through one of the strangest worlds in our solar system, consider subscribing to the Cosmic Observer, because there are still countless mysteries waiting beyond the edge of our understanding. Until next time, keep looking up.